In section 15, we will multiply complex numbers. The use of the calculator is not allowed in this section. So we start by comparing our entrance slip problems to the two problems below. These are examples that are very similar to the entrance slip problems, with the exception of instead of having x's, we now have i's in our problem. And we can see here that everywhere we have an I in our problem, we would have had an x on the entrance slip. So one main difference here is that where we had the x squared, which now is an I squared, that is going to turn into a -1. Therefore, we've got 2 times -1, making this a -2. Now when I combine 35 and -2, I get 33. 5i and 14i combine to give me 19i. In Model 2, we've got, again, the same exact thing that you ended up with in your entrance slip, with the exception of the x's are now i's. And so here we see that that I squared now is going to turn into a -1. -4 times -1 is going to make that a +4. 4 and 2 are going to combine together to give me 6, and then these combine just as they did on the entrance slip. So now I'd like you to take a few minutes to multiply the examples below, and we're going to rewrite them in the form a plus bi. So for number 3, we use the area model. We're filling in 2 and I on this side and 3 and -4i on this side. Now when I go to multiply, I have 3 times 2, so 6. -4i times 2, that gives me -8i. 3 times I gives me 3i, and then -4i times I gives me -4i squared. As soon as we see that I squared, it's best to just cross that I squared off and make this a +4. That way when we go to combine things, we have 6 and 4 combining to give me 10, and then 3i and -8i combining to give us -5i. We'll do the same thing in number 4. The area model, we would fill in 5 and -2i here. We'll fill in 3 and 2i here. From there, 3 times 5 gives me 15. 2i times 5 gives me 10i. 3 times -2i gives us -6i. And finally, 2i times -2i is going to be -4i squared. Once again, the best way to handle this is to cross out the I squared, make this a +4 since it's going to switch signs. Then 15 and 4 can combine right here. That gives me 19. -6i plus 10i will combine to give us 4i. Now try 5 and 6. And here is the answer to number 5. So again, I'm putting 7 and -2i along this side, 6 and I on this side. 6 times 7 gives me 42. I times 7 is 7i. 6 times -2i gives us -12i. I times -2i gives us -2i squared. Once again, I would cross off that I squared, make this a +2. 42 and 2 will combine to give us 44. Then -12i plus 7i is going to combine to give us -5i. For 6, we have 4 and -i on one side, we have 3 and I on the other. 3 times 4 gives us 12, I times 4 is 4i. Then 3 times -i is -3i, and I times -i is -i squared. At that point again, that I squared we can cancel. We switch the sign on that negative to make it a positive, and it's a +1. So now I've got 12 and 1 combining to give us 13, and then -3i and 4i combining to give us I. Another thing here is, again, you can remember this is a -1, and that's why that became a +1. Try the next two examples. And here's the answer to number 7. So here we have 4 times 2 giving us 8, -i times 2 giving us -2i, 4 times 3i giving us 12i, -i times 3i giving us -3i squared. That I squared will cancel. That turns this into a +3. 8 and 3 combine to give us 11. 12i and -2i combine to give us 10i. Then for 8, we have 2 and -3i here, 2 and +3i here. We multiply 2 times 2 to get 4. 3i times 2 is 6i. 2 times -3i is -6i. 3i times -3i gives us -9i squared. Once again, if I cancel that I squared and make this a +9, now these two are my real part, so I add those together to get 13. And then -6i and +6i will cancel, and so I have no imaginary part there. So this answer is just real. Another option for multiplying complex numbers is to double distribute. So if we want to use that method, what we would do is, for this example, we would start by multiplying the 3 by both the 2 and the negative I. And you can write it out like this, or you can just kind of do that multiplication in your head. But 3 times 2 is going to give me 6. 3 times negative I is going to give me negative 3I. Then I times 2 is 2I, and I times negative I is going to be negative I squared. Now from here, I'm going to combine. So I know that this negative I squared is going to turn into a negative negative 1. So that's a positive 1, plus 6, which will be 7. And then negative 3I plus 2I will be a negative I. So I've got 7 minus I for the final answer. Same thing in 10. If I do that method, we're going to be distributing the 4 to both 3 and negative I. That's going to end up giving me 12 minus 4I. Then I distribute the negative I to both 3 and negative I, and that's going to give me negative 3I plus I squared. Now from here, again, the real part is 12, and then I squared turns into negative 1. 12 and negative 1 combine to give us 11, and negative 4I and negative 3I will combine to give us negative 7I. So you can use either method on these. Go ahead and try the next two and use either the area model, or you can use the double distribute method. And here I've used double distribute. Again, I would say you don't really need to write down this step if you want to just kind of do this in your head. But 3 times 5 is 15, and 3 times 3I is 9I. Then 2I times 5 gives us 10I, and 2I times 3I gives us 6I squared. Once again, that I squared is going to change into a negative 1, making this a negative 6. So 15 and negative 6 combine to give us 9, and then 9I and 10I combine to give us 19I. And then for 12, again, use either method. Here I'm distributing 2 to 3, which is 6, and then 2 to 4I, which is 8I. Then negative 5I to 3, which is negative 15I, and negative 5I to 4I, which is negative 20I squared. From there, the I squared is going to cancel and change to a negative 1, making this a positive 20 here. So if I've got 20 and 6, it's 26. And then 8I minus 15I will combine to give us negative 7I. We have two more problems here. Again, use the method that you are more confident with. And here's the answer to 13. So again, I've chose to distribute this in. 5 times 4 was 20. 5 times 6I is 30I. 4I times 4 is 16I. 4I times 6I is 24I squared. From there, the I squared is going to cancel and make this a negative 24. So 20 and negative 24 combine to give me negative 4. 30I and 16I combine to give us 46I. And that's our final answer. And then for 14, I've got 3 times 3, which is 9. 3 times negative 4I, which is negative 12I. Negative 4I times 3, which is negative 12I. And negative 4I times negative 4I, which is positive 16I squared. That I squared is going to cancel, making this a negative 16. So 9 and negative 16 combine to give me negative 7, and then negative 12I and negative 12I combine to give us negative 24I. And the last two that we'll try, go ahead and take a minute to use the method that you're more confident with. And on 15, I've distributed. 2 times 2 gives me 4. 2 times negative 3I gives me negative 6I. 3I times 2 is 6I. 3I times negative 3I is going to be negative 9I squared. The I squared cancels. That makes this a positive 9. So 9 and 4 is going to give us 13. And then our middle terms actually cancel. So negative 6I and 6I are gone, and we just have 13. And then for 16, the same type of thing happens. When we multiply 7 times 7, we get 49. 7 times 2I is 14I. Negative 2I times 7 is negative 14I. And then negative 2I times positive 2I is negative 4I squared. Once again, the I squared is going to change into a negative 1. So cancel this and switch the sign, make it positive 4. 49 plus 4 then is 53. And again, our middle numbers combine to cancel. Now we want to talk a little bit more about these last two problems that we just worked with. Now the answer to each of the products above is which of the following: a real number, an imaginary number, or a complex number. and it should be a real number. So we did lose all of the i's in this problem, and we kind of want to think about why that happened. Well, complex numbers of the form a plus bi and a minus bi, so we can see we have the exact same thing in each set of parentheses. The only difference is that one's positive in between and one's negative in between. Same thing here, this one's negative and this one's positive. Those are called conjugates. The conjugate of a plus bi is a minus bi. Again, the a's have to be the same, the b's have to be the same. The conjugate of a minus bi would be a plus bi. And the product of two complex numbers, which are conjugates, will be a real number. So for problem 17 and 18, we're going to identify what the conjugate is, and then we're going to find the product of the complex number, which we're given, and its conjugate. So for 17, we should have a conjugate of 6 minus I. Again, we keep the real number the same. We keep the imaginary number the same. We just switch its sign. And then from there, when I go to multiply them together, 6 plus I times 6 minus I, 6 times 6 is 36. The outer part is going to give me negative 6I. This part is going to give me positive 6I, so I know that those are going to cancel. And then the last is I times negative I, which is negative I squared. From here, once again, the I squared turns into a negative 1, making this a positive 1. 36 plus 1 then is 37, and the middle numbers cancel. And as we notice that we're using conjugates here, you can kind of start to get in the habit of only multiplying the real parts together to give me 36, and then only multiplying the imaginary parts, because we know that those imaginary numbers in the middle are going to end up canceling. If I use that method, 6 times 6 would give me that 36. I times negative I would have given me negative I squared, which turns into a positive 1. Again, those are going to add up to give me 37. For 18, our conjugate would be 1 plus I. So when I go to multiply these, again, we can do the entire multiplication, or as long as we're confident that these are conjugates, we could just do 1 times 1 and get 1. And then we can go to the imaginary part, I times negative I, and get negative I squared. Again, this is going to make this part a positive 1 and 1 will combine to give us 2. Of course, if you do the full multiplication here, that's totally fine too. It's just that you will get these to cancel each time. Try the next two on your own, and then we will go back and check your answers. So for number 19, when we get the conjugate here, the real part stays exactly the same. So we have to keep that as negative 3. It's the sign in the middle of the two parts that is going to change. So this becomes negative. Positive 2i here, this was that negative 2i here. When I go to multiply those, negative 3 plus 2i and negative 3 minus 2i, again, negative 3 times negative 3 is positive 9. I could do this part and I could do this part, but it will be unnecessary as long as it's complex conjugates, because they're going to cancel. And then 2i times negative 2i gives me negative 4i squared. Once again, that I squared is going to cancel, make this a positive 4. 9 plus 4 is 13, and our I values were going to cancel. And then for 20, our conjugate should have been 5 plus 4i. So if we're multiplying 5 minus 4i and 5 plus 4i, 5 times 5 is 25. On the outside is 20i, on the inside negative 20i, again canceling. And then negative 4i times positive 4i is negative 16i squared. Again, the I squared cancels. This becomes a positive 16. 25 and 16 adds up to 41. Go ahead and complete 21 and 22. For 21, the conjugate should have been 2 minus 2i. And then when we go to multiply the two together, 2 times 2 gives us 4. Again, you can skip these two because they are going to cancel. 2i times negative 2i is going to give us negative 4i squared. Once again, the I squared cancels to give us a positive 4 here, and then 4 and 4 combine to give us 8. And then for 22, the conjugate is going to be 4 plus 3i, and when I multiply them, 4 times 4 is 16. Outside and inside we can write, but they will cancel. Negative 3i times positive 3i is negative 9i squared. I squared cancels, switches the sign here to make it a positive 9. 16 and 9 add together to give us 25. And now I'd like you to complete the exit slip associated with this lesson, and your homework is going to be in section 15.